few problems on different properties of rational numbers. Okay, today we are going to discuss about the properties of multiplication. Okay, listen here. The first question is, name the property under multiplication in each of the following. Who has given some problems? Those are all corresponding properties. Okay, those properties, which are those properties we have to identify. Look here, the question is minus 4 by 5 into 1, which is equal to 1 into minus 4 by 5. Understand? We can write it as this one. See here, 1 is there. Okay, 1. Already we know that. What is 1? Yes, 1 is the multiplicative identity. Understand? Therefore, it is multiplicative. 1 is the multiplicative identity. Therefore, the property is multiplication of identity. Understand? Let us see one more problem. The problem is minus 13 by 17 into minus 2 by 7, which is equal to minus 2 by 7 into minus 13 by 7. Look here, children. Observe the question carefully. Okay, here is a multiplication, properties of rational number under multiplication. Look here, it is in the form of a into b is equal to b into a. Okay, therefore what kind of property is this? Yes, this is the commutative property. Commutative property of multiplication. This is in the form of commutative under multiplication. Next, let us go for the third example, that is minus 19 by 29 into 29 by 19. Okay, here minus 19. Let us see once again write the problem. Minus 19 by 29 into standardized form minus 29 by 19, which is equal to 29 gets cancelled. 19 by 19 gets cancelled. Here remainder is 1 by 1 into minus 1 by 1, which is equal to minus 1 into minus 1. We know that 1 into 1 equal to 1. Here minus into minus equal to plus. Therefore, what is the property is this? Yes, this is the inverse property of multiplication. Multiplicative inverse property. Are you understand? Yes. Now we are going to discuss about another problem, that is multiplication. Writing the problem, multiply multiply 6 by 13 by the reciprocal of minus 7 by 16. Okay, dear students, first read the question carefully. The question is multiply what? 6 by 13. For that, what to do? The reciprocal of minus 7 by 16. The reciprocal of minus 7 by 16. First, solution is, first write the reciprocal of minus 7 by 16. What is the reciprocal of minus 7 by 16? See, the reciprocal of minus 7 by 16 is 16 by 7. That means minus 16 by 7. Actually, you can write 16 by minus 7. The standard form is minus 16 by 7. Okay. For that we have to multiply what? 6 by 13. Therefore, according to the question, according to given, what has given? Multiply what? 6 by 13 into reciprocal of minus 7 by 16, that is minus of 16 by 7, which is equal to how much? 16 6 are? Yes. Minus 96, 13 7 are? Yes. 91. This is your answer. Okay. Next, we are going to discuss about another problem, that is identify the property or compute the property which has given. Next problem, that is tell what property allows you to compute 1 by 3 into 6 into 4 by 3 as 1 by 3 into 6 into 4 by 3. Look here. Write the question once again. 1 by 3 into 6 into 4 by 3, which is equal to 1 by 3 into 6 into 4 by 3. Understand? See children here. See. Here it is in the form of A into B into C, which is equal to A into B into C. Understand? Then what type of the property is this? Yes, this is the associative property of multiplication. Clear children? See here in the place of A, 1 by 3 is there, into B place 6 is there, into C place 4 by 3 is there. Correspondingly here A into B, 1 by 3 into 6 into 4 by 3, that is the place of C. Okay. Next we will pass to next problems. That is fourth one is 8 by 9 is the multiplicative inverse of minus 1 by 8. If it is multiplicative inverse y, if it is not, why not? Give reason. See here, multiplicative inverse of a rational number in word. What is the multiplicative inverse of the multiplicative inverse of a rational number A is S, 1 by A. If A into 1 by A is equal to 1, therefore in the question itself it has given 8 by 9 into minus 1 by 8. Understand? See here, 8 by 9 into this mixed form you have to write in the form of improper form. 8 ones are 8 plus 1 10 by 8. Sorry, 8 ones are 8 plus 1 9 minus 9 by 8. Look here, 9 gets cancelled. 8 gets cancelled here. 1 by 1 into minus 1 by 1. 1 by 1 is nothing but 1 into minus 1 by 1 is nothing but minus 1. 1 into minus 1 equal to minus 1. Therefore, right here, therefore 8 by 9 is not a multiplicative inverse of minus 1 by 8. Understand? Okay, next we shall move to next problem. That is the same time one more problem is there. Write down the problem. The problem is, if fifth problem is 0.3 the multiplicative inverse of 3 1 by 3, why or why not? Look at children, the same steps will be followed. We know that the multiplicative inverse of the multiplicative inverse of a rational number, multiplicative inverse of a rational number, a is 1 by a. Okay, suppose if a into 1 by a equal to 1. Understand? Next step is 0.3 into, what is the fraction given? 3 1 by 3. Okay, we know that decimal form, decimal 0.3 we can write it as 3 by 10. Okay, here 0.3 into 3 3 is a 9 plus 1, 10 by 3. The standard form of 0.3 is 3 by 10 into 10 by 3. Therefore 10 gets cancelled, 3 and 3 gets cancelled. Then remainder is 1 by 1 into 1 by 1, 1 into 1, which is equal to 1. Yes, therefore 0 by 3 is here, right? Therefore 0.3 is the multiplicative inverse of 3 1 by 3. Why? Because after the at last we are getting 1. Therefore 1 is the multiplicative inverse. Okay. Now this is the end of exercise 1.1. In the next class we are going to discuss about 1.2 exercise problems. Okay, before going to that, first let us understand number line. How to represent numbers on number line. Especially in this lesson we are going to represent rational numbers on number line. First, number line. Number line. What is number line? Line means we know that line is a straight line. Straight line means what? Line is extending endlessly in both the directions. Understand? But here in the same extending endlessly in the line, on that line we have to represent numbers. Suppose it is a number. It is what? What is this? This is a line. Okay. In the middle of the 0 is there. 0 to left side numbers are negative numbers. -1, -2, -3, -4 and so on. Okay. 0 to right side numbers are positive numbers. 1, 2, 3, 4, 5 and so on. Okay. Next, here if they ask represent plus 3 on number line. Okay, this is an example. Just represent plus 3 on number line. We know that what positive numbers means 0 to right side numbers are all positive numbers. That is 1, 2, 3. This is what plus 3 indicating. Here right, plus 3. Next, represent minus 2 on number line. See here, 0 to left side numbers are negative numbers. 1, 2. This is the minus 2. Are you clear? But here, up to this, we learned in the last classes. That means last year. But this year, we are splitting. See here, for example, 7 by 4. See, this is a new type of the problem. Okay, 7 by 4. How can we represent 7 by 4 on number line? Yes, write the number line as it is. Okay, see, the given number is positive. Therefore, write 0 to left side is negative numbers. Negative numbers for us no need. 0 to right side numbers are positive numbers. But here, clearly we have to understand that we have to take care about the denominator. Here denominator is 4. That means what? Each group is separately divided into 4 equal parts. 1, 2, 3, 4. Okay? Here, one portion. Next, 1, 2, 3, 4. 2. 1, 2, 3, 4. 3. But divide the given rational number by the denominator. If we divide 7 by 4, 4 ones are 4. Remainder is 3. This 3 goes to numerator. 4 comes to denominator. Quotient as a whole part. Understand? Therefore, representation of 7 by 4 on the number line is CN. This means this is 1 by 4. This is 2 by 4. This is 3 by 4. This is 4 by 4 is nothing but 1. 2 by 4 is nothing but half. Next, 7 by 4. Here is 5 by 4. This is 6 by 4. This is 7 by 4. Are you understand, children? Therefore, here at the place of the 7, count 1, 2, 3, 4, 5, 6, 7. This is what? 7 by 4. 7 by 4. Also, we can write it as 1, 3 by 4. Understand, my dear children? Okay. In the next class, we are going to discuss about number line problems. Okay. Number line problems, especially on rational numbers. And also, see, in this next class, I won't tell you again. See, here 2 and 3 are 2 numbers. How many numbers are there in between 2 and 3? Your answer is wrong. See, there are in between 2 and 3, there are plenty of rational numbers. There are uncountable numbers of rational numbers are there between 2 and 3. Or in between any 2 numbers, uncountable or infinite numbers of rational numbers are there. Okay? Okay, children. Thank you, and I'll make these notes. Shortly, we will conduct your tests, oral after written test. Understood? Okay. Thank you very much, children.